everybody. Mr. Smith here, and we're shooting a video on an application of inverse matrices, and that application is encryption. So this is a introductory, kind of a basic level encryption. This wouldn't be something armies and governments are using right now, but it's kind of like a gateway, an entry into the world of encryption. And it's still pretty neat. So I'm going to show you guys how we can do encoding and decoding messages with a matrix. So to do that, we have to kind of agree on some set ideas. One is that we have 26 letters of the English alphabet, and we're going to assign the numbers 1 through 26 to those 26 letters in this way. Now, if you want to encode in a different language, you can, add more letters. You could add punctuation. You could add emojis. You could literally add whatever you want to do. But we're just going to encode simple messages with 26 letters. And the idea is to scramble a message. We're going to encode it with what I call a key matrix. So we're going to use the matrix 3142. So we might call this the key or possibly the encoder matrix. And one very important piece of information about your encoder matrix is it has to have an inverse. It has to be invertible. I'm shooting with my Sicky Asher here, so he might make an appearance. The dog might make an appearance. I don't know. That's just the joys of working from home. But your key matrix must be invertible. So keep that in mind when you make up your encoder matrix. I keep it simple, but you have to make sure it has an inverse. For example, I'm going to erase this in a second. But using a matrix like 1, 0, 0, 0 looks convenient, except the determinant of that matrix, 0 minus 0 is 0, and there's no inverse, and you wouldn't be able to use it. So make sure it has an inverse. So we're going to encode just a simple word, and we're not going to encode huge messages. You could program a computer to do that possibly. We're just going to encode, something that doesn't need a ton of space to do. So in honor of the lobster gate last week, we're going to encode the word lobster using our key matrix. So how do we do that? First of all, we have to turn lobster into a string of numbers. So we'll do that first. So lobster, and then maybe underneath it in pink, I'll write the letters that correspond to lobster. So 12, 15, B is 2, S is 19, 20, E is 5, and R is 18. Now, to encode with a matrix, we need to take these string of numbers and put them into some 2x2 matrices. So let's do that. And you can have your own conventions for doing this, but for me, I just start and just fill it in left to right. So 12, 15, 2, 19, and I need another matrix to store this information. I'm not multiplying these matrices. These are just two separate matrices I'm using to store my information. And then I have 20, 5, 18. Now, if your code isn't a multiple of 4, then for your final entry, you do need something in there. So we're going to include a placeholder of 0. So you can pop in placeholders whenever you need to. You could also put in, if you really wanted to, you could put in zeros for spaces if you wanted to actually have spaces in your message. Totally kind of up to you. But that's how we handle 8 entries in a matrix and only 7 letters. Okay, so now we've taken our message and we popped it in. Now, if you just gave this message to somebody, 12, 15, 2, 19, 25, 18. It's, for people that have experience, it would be pretty obviously we call that a Caesar cipher, where it's just like the numbers correspond to letters, and it'd be pretty easy for somebody to work backwards and figure out you wrote lobster. Even if they found these matrices, like they could, by putting the letters back in, they could probably figure out what the word is. So we're going to encode our word lobster there. So now we're going to encode. How do we do that? We're going to take our encoder matrix, which is 3, 1, 4, 2, and we're going to multiply that by 12, 15, 2, 19. Sorry, Asher just never shuts up, so he's just making noises. So we'll do that. And then we also have a second matrix to encode. So we'll take our encoder matrix, our key matrix, 3, 1, 4, 2, and multiply it by our second guy, 25, 18, 0. So multiply every message that contains your code by the encoder matrix. So we just need to do these two. And so I'm shooting this video lesson. I'm going to do this work here. So if you're watching as a group, or if you're watching independently, you have the flexibility to pause anytime you want and just try things on your own, to rewind, fast forward. So I'm just going to proceed. But yeah, again, I wouldn't be insulted if you just like pause and tried it on your own, or kind of just like, if you want to just follow on with me, that's fine too. So I will show an intermediate step as I normally do. So 3 times, so 36 plus 2, and then 45 plus 19. 4 times 2, 48 plus 4, and 60 plus 38 gives me 38, 52, 64, and 98. Okay, and let's get our second. So that would be 60 plus 18, 15 plus 0, 80 plus 36, and 20 plus 0, which gives 78, 116, 15, and 20. So we've encoded our message now. So if we were sending this encoded message to our friend, we would, starting as like we did when we encoded it, so like working left to right, or we would send this encoded message: 38, 64, 52, 98, 78, 15, 116, and 20. So we would send them that message. Now that is completely encoded, not obvious at all what those numbers represent as far as letters. But if we just sent that message to our friend, they wouldn't know either. What they need is they need the decoder matrix. So you have to send them, along with this message, you would send them the encoded message and your encoder matrix so that they can decode it. And here's how they would decode it. To decode it, you need to undo the encoding you just did by finding the inverse of your key or decoder matrix. So we're going to find the inverse of 3142, and just want to make sure, yeah, we have lots of space down there. So in class, we have just been, checking the determinant to make sure it has an inverse. So here, the determinant would be 3 times 2 minus 1 times 4, which is 6 minus 4 is equal to 2. And so using our rule for finding the inverse matrix, the inverse would be 1 over that. We swap the two entries on this first diagonal, and then we change the sign on these diagonals. Now, 1/2, fairly nice fraction. Most of you guys don't like working with fractions, so it seems good here to write that as a decimal. So 1/2 times 2 is just 1, but then 1/2 times -1, let's use -0.5. 1/2 of -4 is -2, and 1/2 of 3, let's use 1.5. So that's okay. That will be fine for us to work with. No crazy decimals or anything. But this would be our decoder matrix. Now, so our friend needs the encoded message and needs the original matrix A in order to encode it. The original matrix A, could be something you guys, or whoever you're communicating with, you guys all just know, or maybe you have several decoder matrices, like depending on like the day of the week or day of the month, et cetera, et cetera. You can have your own rules for that. But yeah, the big idea is you need the encoded message and the, Asher is singing the Squid Game song. Okay, Asher, quit distracting me. Let's continue. Okay, so now we can decode the message. How do we do that? Well, we take our encoded message as matrices and multiply it by our decoder message. It's important we do the decoder message first, actually, when we multiply it. So we have these two multiplications to do. You guys have this on your page. I have to flip back and forth because I'm 40 now and I have absolutely no short-term memory. 1 -0.5. -2 and 1.5. Okay, and the first four numbers in our encoded message, 3864. 3864, I think it was 52 and 98. Now, obviously, we know what the decoded message is. It should give us lobster. We're just kind of seeing how this works. And then our second matrix multiplication is going to be 1 -0.5, -2, 1.5, multiplied by 7815. 7815, I think it was 11620. Again, you guys have this on your page. I have to flip back and forth. Okay. Yeah, so once we do these two multiplications, we should get our original numbers that correspond to the letters in lobster. So let's have a look. Now, full disclosure, my last time I gave this lesson, I used a different word. And I did a big no-no, and I'm doing this right now with you guys without having done it ahead of time. So hopefully I didn't make any mistakes. If so, we'll catch them. But yeah, let's dive in. So that would be 38 and then -26, 64 minus 49, -19 plus, I'll have to be careful here, half of 52 is 26, 78, minus 128 plus, that would be 147. And what do we get? 12, 15. This one doesn't look right. Yeah. -19, that should be -76. This one was fine, 15. All right, so if you were screaming at the screen, we found our mistake. It's okay. -2 times 38 is actually -76. That gives us 2, which is good. And -128 plus 147 is 19. Let's do our next one. We get 78 minus 58, 15 minus 10, -156, 1.5 times 116. half of that is 58. Add 58 onto that, plus 174. And we get negative 30 plus 30. All seems to be working out, I think. 20, 5, 18, and 0. And if we put, and so our decoded message, if we combine these two things together, our decoded message would be 12, 15, 2, 19. Right, more compact. 12, 15, 2, 19, 20, 5, 18, and of course 0 is just a placeholder, which corresponds exactly to our encoded message from earlier. And then we obviously know the cipher, those letters of the alphabet, LOBTER. So we have talked about how to encode a message, but also once you have that encoded message, how to decode it as well. All right, so I have another word for you guys to try. So Asher chose this word. We are going to encode and decode the word poopy. And we're going to use the same key matrix from earlier just to save us some work. So we don't need to find the new inverse for that. So this would be a great time to pause the video and actually give this a try yourself and encode it and decode it. So you just get experience doing both. So you can pause the video and try that. Or if you want to follow along, I'm going to do it as well. Just so you can either watch along with me or you can watch it later to check your answers and fast forward as you like. All right, so let's dive in. So first of all, poopy, we need to write that as a string of numbers and put it in a matrix. P is 16. So 16, that would make O 15. 16, I is 9, and E is 5. And then we would store these in some matrices. 16, 15, 15, 16. And then 9, 5. Now, poopy is only 6 letters, 8 entries in these two matrices. So we put in some placeholder zeros. You love to see it. 0 is easy to work with. Just going to double check those letters are good. 16, 15, I is 9, E is 5. Okay. Okay, let's encode. And again, at this point, you feel free to pause and then do it yourself, and then you can fast forward through my work here. But yeah, our encoder matrix was 3142. And then 3142. So for the sake of time and space, I might just go right to the final values for this. Feel free to. There's lots of there's lots of space here, so I'm okay with you guys just going right there. But I won't be lazy. I'll just do it. After all, you guys can just fast forward through this if you really want to. So 48 plus 15, 45 plus 16, 64 plus 30, 60 plus 32. I think this stuff is very fascinating. Maybe you agree. But it's just neat how, just by a simple matrix multiplication, you completely, to the average person, it would not be obvious at all what's going on with this encoded message. Like they'd have no chance of figuring out what it said. Okay, there's that guy. This one should be easier. Yeah, because the second is always going to be 0. So this one is just 27, 15, 36, and 20. So our encoded message we would send would be 63, 61, 94, 92, 27, 15, 36, and 20. Great. So we've encoded the message, and now just to double check that this works, let us decode. So we're using the same encoder matrix, so the same inverse. Keep in mind, if you're doing your own with a different key matrix or different encoder matrix, you need to find the inverse for that one. So for us, it was 0.5. It definitely wasn't that. It was 1. And then negative 0.5, negative 2, and 1.5. But I am going to double check that. Yeah, 1, negative 0.5, negative 2, 5. Okay. And we need to multiply that by our encoded numbers. So 63, 61, 94, 92. And then 27, 15, 36, 20. We know what to expect coming out again. We should get the same encoded message. We should get poopy. Let's begin. 63 minus 47. 61 minus 46. Negative 126 plus 47, 141. Negative 122. Oh boy. 46, 138. And we get 16, 15, 15, 16. Looks familiar. And for this one, we get 27 minus 18. 15 minus 10. Then we get negative 54 plus 54. Negative 30 plus 30. 9, 5, 0, 0. So our decoded matrix, 16, 15, 15, 16, 9, 5, and then 0, 0. So I just won't write them, which corresponds to the letters P-O-O-P-I-E. Other words, poopy. We did it. So you guys now have 2 examples in the books of encoding a message and decoding a message. Here we used a specific key matrix, 3142. In practice, you make up your own key matrix. You give that person who you want to decode the message, you have to give them that key matrix. So what I have you guys working on now is an encryption task. So I actually have that brought up here. So I've encoded a message for you, and I've given you the encoded message, and I've given you the key matrix. So you have to uncode the message. Is it a dad joke? Is it some words of wisdom? Who can say? You have to decode the message. So I've given you this key matrix. I've made it pretty straightforward so that you could find the inverse pretty easily. So this would be in the examples we did, we just called this matrix A. So everybody's decoding the same message. So please try it on your own. But obviously you can check with your friends, and you guys should all get the same message. The second question, you're encoding a message to me. You can decode it if you want to as a check, but all I want submitted here, because I don't want to, I'm going to do it. Don't spoil the fun for me. You're going to encode a secret message to me. So all you're submitting in this assignment is your encoded message, and you're giving me the key matrix. So just like I gave you an encoded message and key matrix in one, you give me the same thing, but a personalized message. It can be just like some random word or phrase. However, it should be um, um, it should be 9 to 12 characters long, which basically means you'll need to store it in 3 matrices. So you could do. I don't want like a huge like paragraph, so just keep it to 3. But I'd like you guys to do 3 just to just for kind of a next level problem. I have given you guys a kind of restriction here to make my life easier when I'm decoding your messages. Please make sure your key matrix has a determinant of 1. That makes the inverse very easy to find with whole numbers for me, and it makes my multiplications a lot easier. So a simple way to do that, you can choose whatever, you choose a different one than this though. But let's say you choose some numbers on the first diagonal. Let's say you choose like 4 and 5. If I need my determinant to be 1, when I do my determinant, I'll be doing 20, subtract whatever's on the other column. And to get 1, it must be 19. Two numbers that multiply to 19 are 1 and 19. So that's an easy way to cook up a matrix with a determinant of 1. You cook up your own one. I use smaller numbers for my example. If you notice that 3 minus 2 is equal to 1. But yeah, make sure your determinant is 1 to make it my life easier. Okay. If you do happen to get this task done today, there is some extra practice contained in the lesson sheet that you can work on. And there will be built-in time in our following period for you guys to work on this message, work on any unfinished assignments. All right, so I hope you guys enjoyed that. Please feel free to reach out if you need a hand with anything, and hope you guys are staying well. We'll see you guys soon.